right? Effective rates and the present value of an immediate payment stream. So in this example, we will be changing a nominal interest rate into an equivalent annual interest rate. So that's kind of the purpose of this example. So let's go through it. Marope is purchasing her first home. She has saved up a down payment and has worked with her financial planner to determine that the maximum mortgage payment she can afford is $750 bi-weekly. If Marope takes a 25-year mortgage at an annual interest rate of 6.99% compounded semi-annually, what is the maximum mortgage amount she can afford based on her maximum payment at the end of each bi-weekly period? So there's a lot of different time time references here. There's biweekly payments, and the interest rate is compounded semi-annually. So we have to make them all the same so that we can calculate the correct interest rate and therefore be able to calculate her the maximum payment she can afford accurately. So let's get to it. So the solution. So since the compounding frequency is semi-annually, but the payments are bi-weekly, all right? Compounding is semi-annually compounding. And the payments are bi-weekly, right? Bi-weekly payments. The equivalent rate is calculated and adjusted to reflect the frequency of compounding and payments. So how do you do that with our Sharp financial calculator? So let's go ahead and clear it. Second function alpha 0, 0. So we have so we're changing from a nominal to an equivalent annual rate, all right? So basically I have the steps that we're doing here, and I'll just explain as we go through it. So step 1 is converting the nominal rate to an effective rate to reflect the compounding frequency. So the compounding frequency is 2. So you do 2, and then this XY button, and the nominal interest rate is 6.99, and then you second function to EFF, the effective interest rate, and that is 7.1122%. So now you want to convert the effective rate we just calculated to the equivalent rate to align with the payment frequency, which is the biweekly. So that's 26 payments a year. So we clear the calculator again, or just on off clear it, and so the payment frequency is 26 times per year, and XY, and using the equivalent rate that we just figured out was 7.1122, and then second function and this ARP button, which is also the payment button. So it's the equivalent rate is 6.8798%. And the third step for this equation, or for this example, is you'd still need to divide the 6.8798 by 26 to get the amount of payments. Like, so she's paying it bi-weekly, so you still need to divide the equivalent rate by the payment frequency. All right, so 6.8798 divided by 26 equals 0.2646%. So that's the percentage that we're going to use in this calculation, which is on the next page, and it's over here. So these steps are what I just explained on basically, hopefully, sorry if this is unclear, but each step represents step 1, step 2, step 3. So if you're wondering what you're doing, going through this question, it's this. And now let's go for the solution, the final solution. I'm just going to fold this over and try to make it clearer, but I think I might be doing more harm than good. But here's the solution. So the mode is end, because she's paying at the end of each biweekly period. The future value is 0. The interest rate is 0.2646, which we just figured out right here. Using the figuring out what the equivalent interest rate is. And it's the time frame is 650, and that is calculated by 26 payments per year for 25 years. So 26 payments per year times 25 equals 650. And the payments that she's going to be making 26 times a year, whoopsies, is $750 bi-weekly. So $750. Okay, so let's figure this one out. So the mode is end, and we're in beginning here. So we're going to go ahead and second function FV. Oops, I hit it too many times. Second function FV, and now we're in the end mode. So let's go ahead and clear this calculator again. Second function alpha 0, 0. So 0 future value. Interest is 0.2646 interest for 650 is the time period, 650 months, I guess. And our payment is 750, and it is a negative because it is leaving her hands and going into to pay off her mortgage. And that's payment. So compute present value. So Marope can afford a maximum mortgage payment of $232,570 based on her maximum payment amount of $750 if she takes a 25-year mortgage at an annual interest rate of 6.99% compounded semi-annually.